See, already the CPU usage is lower. Uh, climbing around, but different, anyways. And we'll see if see how that works. So futures, futures. I am also an old school C dev, loving Rust though. What did the fish say when he swam into a wall? Damn. Okay. Yeah, we deserve that. We deserve that. The face just makes it. Okay. Ah, okay. I know I'm gonna regret this. Gonna regret this. VBox. We're going to need some sort of structure to be able to hold the children inside of it. Sorry, I'm keeping an eye on the drop frame rates, just because, I'm hoping that this really fixed it. We'll see how it goes. Little one, good morning. Happy Thursday. All right. So we need something that it's basically the children of this, things that this is going to be, I don't know, managing. So here we have children. At one point, I was in a project that had a lot of the word children all over it. We ended up saying childs just because it was faster to type, and we were typing it all the time. Gotta take the lid off. See, we got this purple thing here. Our super hot scalding tea. It's like an orange spice this morning. I don't hit caffeine until about 10 a.m. or so. But we got the funk. Okay. So we'll have children, and this will be some sort of list vector, and it'll be a vector of 9 foo-bars. Something that can hold, because the children might be of different types, right? So we need to have some sort of foo-bar trait. And what is this foo-bar trait? We're going to need to say, this is your space. So it's basically, foo-bar is going to be able to tell and ask the children, what is your size? And this is your sandbox. This is your space to live inside of. What would that look like? Great. Foo-bar. We'll rename it. We're going to have a function size, and this should return some sort of size. This is going to be from, I don't know. This is silly, but Leon has these fantastic aliases for these. We could duplicate this, or we could just use the ones from Leon. We'll just use the ones from Leon for now. Set box. So we need to be able to ask it, how big are you? And then where your space is. Math, path, math. Okay. Is there anything else we need from that? So coming back to, oh, I killed off A Sprite. Really, I killed off A Sprite. That's still there. That's weird. Because we're gonna have the children in these squares like this. We're building this V box. I want to say, how big are you? So we can position the next one so far down. And then we also want to be able to say, this is your playground. This is your box that you live in. No. We might need to do this one after the next. That, and we need some way to know that the size of the child has changed. Because if the element inside the child changes, then we need this whole flow to happen again. How do we wire that into this? We could have the VBox or we just listen. Because we could use signals for that. Kind of a side channel sort of thing. So we either have foobar or signals. And the signals would be size changed. I know it's a little dark there, but what else? Because if the contents changed, let's say the text changed or something else happened, I mean, we could make the game such that we just swap out the components, right? Delete them. And this is going to need to preserve some sort of order because we might have a number of elements between them. Because maybe, just maybe, we wanted to reparent this to a new node, some other spatial thing, right? And it sits in here somewhere. So this is actually going to climb up through its DOM. Browser day job is getting me. All right. Climbs up into this, detects that this thing implements some sort of interface, and then registers itself. But then how does spatial know? Maybe it only works if the parent? Yes, yeah, if we're climbing up through multiple things, no, this one needs to be aware. So maybe it's only one layer. All right, let's just do one layer for now, like that. The dropped frames, we're looking better. We're currently at 2.3, but I think that's for normal Starlink droppage. All right. So we'll have this, then we need to export some sort of function that we can check to see if it exists. And for that to use the has method, so we should be able to detect, do you have this method? So we'll just say, hey parent, do you have this method? If you do, then we'll call it. These here, has method, has signal. And then the parent could ask the child, do you have the signal? If you do, register and listen to it. Do signals in Godot get cleaned up if you remove an object that had been registered on that thing? All right, so let's do that. Let's see if we can climb the tree, see if it implements a specific method. Export name, interesting. Export pub function. I don't know, like some sort of register or register child. Who knows? This is going to take owner and then child. And the child is going to be a what? This is actually going to be a tier of spatial, isn't it? Because it's not going to be the script that comes into this. It's going to be the node that the script is. Traits in this because this is exported, so we have some limitations. What's another way we could do this? We could flip it and say, hey, you are of this type. Therefore, I know that you are one of these very special things. To maybe this thing, the container, and this would have like a register child or something. But we need to be able to detect this. Because we can get the type. Well, we can get the object and we can get the script, but we do not know what the type of the script is, or if that type implements different traits. How do we do that through Godot? Could get the class. Where's our IUnknown? I mean, really, that's what we're doing here. Are you this type? What do you expose? Container. box 9 container. Can we do this with Godot? Oh goodness. Say your default. I don't know if we can have that sort of abstraction there. Exported methods must take self. Oh yes. Self and owner. What? All right. Okay. This pattern, we could fill this out. Just thinking through this, if this works, if we can return something like that. The problem with this is that we have to return one of these or a reference to one of these, which is that how you would do this in Rust? Yeah, like um, can you strip away the box and just say we're going to return the type interface here? Oh, two variant and this is strange because I'm trying to get something that has more type information through something that has less. Shoot. I gotta see a lady about a goat. So normally the goats will get up on the stand. Yeah, we have goats. They'll get up on the stanchion all by themselves so they can be milked. Um, oops, that's not gonna work. So I'm gonna be right back. It should take less than 10 minutes. I'm gonna put up a little thing for 10 minutes. Um, but we have a timid goat. Doesn't want to get up there. All right, give me a couple. Be right back. Oh, goats. That's right. That's right. All my followers are called goats, the greatest of all time. That's one way to interpret it wordly. All right, give me just a sec. I gotta. The stash actually gets some moisture accumulated on it in the cold. All right. We're going to try to return something here, but because the export, it needs to be basically two variant, owned variant. We could do something that's a bit more unsafe. We can just basically know it's that type and cast it. Or we use signals, basically have them listen to each other's signals. But then all of the children are going to be listening to different signals, like to each other's signals. And it'd be great if we could do something like this, but we can't. Unless this is somehow. I mean, that thing would also have to implement the variant. Wanted two owned variant too, didn't it? Yeah, I know it's not implemented for box. All right, two variant, there we go. Morning, Jummit. Good morning. That's interesting. but we would have to give it a variant. It would have to be this isn't going to translate well. Trying to think, can we hide this thing via cells or some other thing? So we could create some other sort of container type, some sort of facade. Or it's some kind of middleman in this setup. Because we have a VBox, right? And then we have the child. But in order for them to interact, we need the child to be able to say, hey, I exist. And then for the parents, the container to be able to say, go to this location, be within this box. This is your boundary. Alternative. Floodgate. Yes. Actually, when I first started the stream, I also um, had the webcam, but it's changed. It's changed over to, well, the face has changed. I didn't have the mustache then. This is my COVID mustache. So, sorry. I gotta get some wax on it. I just don't bother waxing it before I come out here. I don't think I have my desk wax out here either. No, I don't see it. But I use a wax called Death Grip. Death Grip mustache wax. So if this container also implements a variant, what does that give us? I mean, really, this is I really don't want it to be like that because it's not like we're. I mean, we just want to give a reference to it. We don't want to. We don't want it to be a copy. We want it to be the right thing, the whole thing. Uh, for some reason, I don't think this is going to work. Well, why don't I think it's going to work? Because we would have to somehow encode a reference to the VBox inside of whatever we return there. But it has to be a variant, and the variant then has to be Godot types. Yeah, variant arrays, results, etc. And that's going to create a copy, which we don't want. So let's not do that. Can't. that, but we can pass in the child. The child can register its container. Either we do it this way or so like a 2 instance? How do we get an instance? Let's say we had a native class or a script. We'll probably have TRefs. Cast instance, here we go. It'll give us a ref to a ref instance, which we could then claim, or we just pass the ref instance, which would be fine. But then we have to manage the lifetime. Not bad. Cast instance, huh? Downcast ref instance, where self is the base object. Yes. Because then from a ref instance, we can map mutably, and invoke functions on those. I don't know, this song's a little aggressive. Vocals are actually distracting. Ref instance. Keep running into issues because of export here. We cannot use the generics on the export. It's not like we can stamp out a whole bunch of these, like for T, where T is of native class, yada yada, right? That's just not gonna work. It's a trait. We can't have a trait there. Can't have more than one function. We need a single function to be exported. I mean, we could box it. All right, how would we do this with Godot? Just pass up the owner. We'd have some sort of check on the network again. Because We had something that was spatial. Basically, it's anything that's node, really. Node and object. And this is object, not Godot object. Object is a reference only type. Yes. So we could say anything that's a ref object. Then when we register the child, we'll have to cast it to object. It's going to be a vector of ref object. How do we know what index this is? Does node have? Maybe I'm doing this the wrong way. Maybe we should have parent listening for events, and then when an event happens, they can add it to their network. What are the signals for that? Let's pull this up in Godot, scripts, help. Signals. When the node. If called on the first channel, the position 0. I see. Node added? Oh, it's on scene tree. Oh, that's right. Oh, that's fine. uh, Middle whenever the A node is added to the scene tree. So we could get that event, check to see, are we the parent? And if so, set up our children again. That's one way. Then we would have a node. And we could put functions on it. That would work. It's actually a common pattern you use? Oh, nice. Very nice. Get rid of foobar for a minute. I think I was using this somewhere else. No. Because if we want to add something here, okay, so let's create some utility functions because we're going to need these. Bunch of these. So all of these common container types are going to have a whole bunch of the same sort of shared code. Node added. This is going to be, a node. And we want the function that needs to be called. How's that? Just make that a stir. No, this is owner, isn't it? It could be node, could be something else. Is that scene tree? Oh, we have to assume safe first. Wait for nodes to be added and then extend, modify, use them in some way. Yeah. Typing is so hard some days. Scene tree. Does that, come on, owner, assume safe. Um, unchild added. I know, like your hands are just off a little bit or something. It's not a ref. It's a T-ref, so we should be able to deref it and then call. Where's the scene tree on this? Is it just get tree? It is get tree. Then we get the tree. Oh yeah. I was thinking that we're actually returning that. We're not. Expect Godot. Now if we do a connect here, we can give it the element, which should be a child, or I guess it's a node in this case. Because we're going to be connecting this. So whatever the signal is, the target, which would be our object, so the signal is the callback, owner. Oh, the method. Oh, wait, no. That's the other value. Signals here. Go back. Node added. Callback owner. And that'll provide a node. All right. Wrong connect. This one. And we need the bindings, binds, and flags. That's going to be an empty variant array. They shared. And then this one, which I think the flags here are just 0. Where's our connect flags? API, object, connect flags. If we could do reference counted ones. Let's look at the docs on those. Connect persist. There we go. This. We get a result back or a Godot error. Back Godot. Eventually I'll be wiring up this expect Godot to some other type. Well, so that we have some sort of logging back to some central point to track errors, etc. Unsafe. Owner. Well, then how are we supposed to accept this if node, say, let's go to scene tree. Yeah, we don't have signals in here. Forgetting. It's a ref node. That's what it needs to be. Or tref node? Can we do tref? Let's see. Hmm. Just a ref. Oh, good. Okay. So if that's our child node, let's check to see if the node's parent is us. And I wanted to add one other thing down here. As method, I want to ensure that I'm guarding for myself. Ensure that this exists. If this does not exist, then maybe this is something that will debug assert here. Owner has that. I think we can provide a message here. All right, well, thank you. Goats. Goats will be goats. Hey, Reed Rayner, how are you? Good morning. Where'd my other glasses go? I'm wearing my non. Oh, here they are, way over here. And I've even got like old man reading glasses. A little dirty. Clean them up. I have them in this vibrant red color so that I find them in low light. Nothing worse than trying to find glasses when you can't see, right? Um, Check this out. Fancy. There we go. Now is node child. We need to check to see if this is the parent. Oh, movie night in an hour. Lovely, man. Very nice. Very nice. You know, more than it had been. But the network is the last piece. All right. Assume save. Should this be an unsafe function? Probably. Get parent. What is find parent? Oh, that's crazy. We can get our position in the parent. Get our parent. Let's just get the parent. Or find. Oh, we need to know that that thing there is the same thing as the owner. Added child. So get parent, that strips out the option. Then we have the ref. We need to assume safe on that. And then we have a tref. Now that tref, is it identical to the other one? Let's not double this up. Oh, thank you. Yeah, I came home, put these on, and the family was like, I don't like them. I think they're fine. Interesting. So how can we tell if the TRF is identical? As we compare the refs? Oh, I did pour some tea before. Does Node have something? Node. know that two things are identical. We could get the pointers and compare them. That seems a little much. So if we come back to ref, I think tref has it, but yeah. Cool. I didn't think that this was going to be a challenge. Like checking to see if two things are equal. All right, so let's start at tref. That's what our owner is. Instance ID. Huh. So we could get the instance ID and maybe compare those. Wow. One would have thought they just, why would we have equal on this? Fine, we'll do it this way because I don't see another way. So that's if the parent's instance ID is the same as the owner's instance ID. I feel like we're missing something here. If is node child, well, rather if it's not, then we just return, but I think we can pretty much guarantee as long as this is called from within one of these, it's going to be safe. Which can't do it. Okay. I know it'd make it a little bit more ergonomic, but it's not correct. We do it that other way. Because we can't always guarantee that these things are valid pointers. All right, now if that is a child and it was added and the previous one was, we're saying it's a child when it's just a node. That should still work because we're giving it context in here somewhere here, saying it's on this object. What are we going to do here? Child's been added. We want to get its index so we know where it was added. And then we can insert it into our vector at that position. Now, something that's bothering me about this scene tree thing is that we're listening to, oh, it's not in here, it's in Godot. We're listening to a signal that gets emitted whenever a node is added to the scene tree. That's like a global thing. So if we have a lot of containers, this is going to happen all the time. I'd prefer it be local. Re-entered. Then it could register itself. It does put the burden on the child here. That's okay. Let's flip this around. We go into box, box. That's a add to parent container. Let's come up with, let's have our UI utils or something. Let's just drop these extra functions inside of UI mod. We could downcast this to node. Which is the minimal minimal version of this. Node has this tree entered. Okay. So whenever this node gets this event, it will go through and add that its parent. Should work. Like maybe this should be a macro so that we update all of them at the same time. Yeah. Okay, we'll get there. Owner connect. Tree entered. On owner. Yeah, because now we have to give it a function that basically does the same sort of thing. Does this have to be an exported function? Maybe. On tree entered. Parent array. New shared. It's empty. 0. And up here, we would need some other function exported. There's no arguments to the signal. But now we're going to have to call some function that we know about on the parent. Oh. Sorry, I changed that. Thought cast to just leave spatial for now. I don't feel like adding a spec Godot in there. Unused result. Unconnect. Oh, yes. Oh, that's right. And we also want to do the other piece where is it a VBox? Yeah. Oh, well, odd. Let's check that the owner has the callback that we're interested in on tree entered. And that'll give us that. Good. Close it up. It feels like this should be kind of macro based. I add some things to the beginning of the new function, add a couple of methods to it for managing this. Because now we have this little dingleberry that needs to be managed. Yeah, I like the idea of these being proc macros. Because then fixing a bug in one place is going to fix it everywhere. Hmm, hanging in there. All right. So what do we do when we enter the tree? This is our kind of proof of concept. If this works, then we'll jump into the macro side of things. Int parent. What language server am I using for Rust? I'm using COC. Good morning. Mahahas. We've got our little Twitch bot here, if anybody's interested. Uh-oh. We had our little Twitch bot. Are you on? My little Raspberry Pi over there. It's, uh, come back, Pi. The sage to Bob. Bob's my Raspberry Pi. Which I could build stuff in Rust on. Oh, Bob. Bob didn't reconnect to the Wi-Fi. Okay, we're gonna reboot Bob. All right, Bob's been power cycled. It's a COC Rust Analyzer. Sorry, I didn't get to the answer. But yeah, it's COC Rust Analyzer. Come on, Bob. I miss Capitan already. Sleeping on the job. We get the parent. Oh, you're very welcome. And normally we'd have like cool little links and stuff like that, but there's Bob. Capitan. There we go. All right, Bob, you with us? There we go. We have commands, and the one we were looking for was COC. There. In this case, we're getting the parent. Now this turns an option. Like that, this should have a parent. There's what are we going to do with that? Our ref node. We need to invoke some sort of function on it. But ref not have map on it. we have to assume safe, then get the tref. That should give us a tref. Once we have a tref, then we can cast instance. Then once we have that, we can either cast or we can cast instance, which will give us a ref instance, and off of ref instance we can call map and map. Yep. All right. I don't know. We could look. How does cast instance fail? Oh, try from base. Ref instance, try from base. And this here, try get user data pointer. Hmm. You have to cast fails. All right, so that should give us a ref instance on which we can map things. So in this case, we have our script and owner. We do something inside of there, and then that's it. Oh yes, this is unsafe. Both of those here. Let's try to keep this as small as possible. Um, yeah. You don't know what the T is. I don't know what the T is either. Can I see this is... See, I really want to use traits here. Because I want to be able to use this on many different kinds of parents. Owner, get parent. So this is our parent. We don't know what sort of script this is going to be. Neither does it. And native class, that's a trait. That's not going to work. It would have to be something that impulses that. But then it's going to blow us up. Can we box that? Oh. On. Because once we have the ref instance, let's not map. At this point here, we have basically the parent object, right? No, it's not cast. We're going to get the owner of the parent. Let's parent equal that. Parent call. We can invoke a method on the parent. Can we? Can we do this? Because then we have to work. We can't really. I mean, we could tell the parent, "Hey, you have a new child." We could pass the object on child added. Just call that, and then we pass it owner and the index. Position and parent. Position. A person to the voice. Oh no. I know, even with this bright light, I thought I would burst into flames, but oh, that's right. We were going to actually do something slightly different. I've got a crate that helps with this. Where is it? Uh, no, not there. It's in here. All no, it's GD native ext. Is it invoke? Yes, invoke. Returns a result. Fine. If we look at this, tried to wrap this up kind of pretty. In debug, we check to see. We just call the functions. All right, so does not need to be deferred. Yeah, I'm sure import that. We're not returning anything from this. We do not expect to get anything back from this, do we? Am I dropping frames? Occasionally. So we're doing a little bit more real time today. Um, so for those of you that do or don't know, Twitch has this option to have like a real time mode, which is what we're doing today. Yesterday we did not have real time mode, but it basically sends data through faster. Also means that if I have a Starlink drop for any substantial period of time, let's see if I can get this. Oh, there's a little ring there. And you can kind of see I've had a couple of drops there. If I get a drop in that time, we will have dropped frames. And at the moment it says I'm experiencing 11%. It was kind of an experiment today. So we'll see how that works out. I'm expecting with the last few launches that things get better. They've gotten better with the previous ones. So I hope it just keeps getting better. Let's see, this needs to be a set of arguments. Oh, it takes 2 arguments. Really? Oh, the name and the args. Right. And this is not correct here. These types are wrong. We can't have that like that. Yeah, less of a buffer, smaller chunk size. Yeah, and here we're having a good stretch. Seems to be. I mean, I'm starting to recognize the pattern. I'm looking at the app again. Um, but I do wish there was like something between like real time and not real time. Variant array. New. Oh, we should save that to a variable. Args. All right. What do we have on variant array? Love having the docs local. That is such a great thing. In Rust, like I can insert, add a position, and pop, and push. Yeah, that's exactly what I think it is. Um, it's between handovers, and okay, yeah. So I'm in the Pacific Northwest, and actually you can see the trains, the recent launches. This is a map of all of these Starlink satellites. You can see why they only did the beta at the top end of this pattern, because that's where they have the most coverage. So let's see, we're up over here, and I think when a handoff happens, um, we get a little drop. Now the drops are actually becoming less and less. They are much smaller than they had been, but I expect it to get even better in the next couple months as the satellites get up into position. If we look in here, this is a great little site for looking at this. So if we click and look at rising satellites, you'll see some of these are starting to fill in some of these orbits. HTTP 3? Oh, maybe. But it's still it's even an issue with um oh goodness. Like Zoom calls and work calls, right? You'll have a moment where you drop suddenly. But look at how fast these things actually travel across the screen. These things are moving at about 7 to 8 kilometers per second. So I get a handoff fairly often. See if we can, yeah, you can kind of see it a little better there. A little bit more context. But these things, yeah, they're screaming, moving pretty quick. I mean, it's so much better than I had before. Is it 4 megabit per second up and down? Trying to share that is really rough. Uh, so, wife and kids, schooling. Oh yeah, yeah, yeah. All right, there's the args. Now, I mean, the var args there. That seems wrong. Just for like sending one value or var args. Self that call. Well, it's the same signature here, so that must be okay. Oh, oh, my mistake. I did this wrong. We don't have to use a variant array here. We can do this. To variant. Yeah, how do you pass that? Is it via claim? Claim will give us the ref, and then ref, owned to variant and to variant. Okay, so oh, var int. Oh, no wonder. Why didn't you guys tell me a typo there? Okay, yeah, tref has it also. Wait, ref has equal? All right. So we invoke that on child added function, and this is on the child. This would be one of the child elements. Okay, so now let's get that correct. Let's go to the parent, which is going to be a VBox. That's going to call this function. And let's say this is on child added. And we are going to get child spatial and position, which is like an I-64. Thank you, Godot. Yeah, quick is going to be cool. Quick is going to be cool. You deal with WireGuard, so at some point nowadays already. Oh, interesting. Yeah, I wonder if I added something else that had a little bit more buffering to the other end, like setting this up to go through a VPN or something else would improve it. But I'm not sure. I mean, the latency is it's incredible here. And, 6. Ping the Cloudflare. That ping, so. Oh, but there you go. And you can kind of see, like there's definitely a pattern to this. It goes up and down. And I wonder if this has to do with handover, etc. Like there, it paused for a moment. Hey, look. But sub 25 millisecond ping time for me would just never happen. Like in the archaic hardware that I was using, it had a 25 millisecond delay built into it. It was old. So I think my previous delay was between like 115 milliseconds was like the best I could do because of that stuff. All right, we no longer need this child as node. I mean, we could validate it. Say, hey, only do this check in this case. Or we could just trust that we do it the right way. That goes away. And we're going to add the child. Self.children.insert. All right, so then we have the child. Oh, object versus spatial. Whatever. We could cast that. Fiber. They're running fiber now, but not where I am. Actually, within a mile to me is a fiber line. I actually looked into getting that set up. It would have been between $1,000 to $2,000 a month. And for whatever reason, this area right here didn't qualify for the rural internet blah 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 thing where they get some sort of subsidy for running fiber. However, that way, 2 to 3 miles did. So whatever, Starlink. So then we have the child added. Now, once we have this, we can start to invoke functions on the children. We could say, what is your size? this is your size because we can use very simple types for that. Integers, floats. So we can communicate this information across those. We might need to implement um, some new types for rectangle, etc. Or we basically create those types ourselves. All right. When a child's added, we're going to call self.layout. And then layout, I mean, maybe that should be a deferred call to layout. I dropped out for a minute. Yeah, usually my drops don't happen as much if I'm doing the buffering on the Twitch side. I might go back to that, but it does introduce quite a bit of a delay, like 30 seconds or so. But none of my drops are 30 seconds long. My upload speed can recover well enough. Nah, your fault, you jinxed it. That's funny. Yeah, it's basically this. Where's Firefox? I don't think they give us too much information. Right, they went to full-time low latency in 2019. Um, latency to broadcaster under video stats, yada yada. I think it makes sense to have that enabled. I'll rather go back to the old mode. Yeah, and if I hit it now, I don't think it's going to change it for the stream. Oops, wrong button. Yeah, Starlink. Yeah. I don't know what layout's going to do at the moment. We'll just give it a stub. Now, hmm, actually had some encoding and rendering lag. I wonder why that happened. That's strange. All right, so in this case, we'll have layout. That. So now the child is going to register itself. Also means that make some of the to macro. I don't think I had any other utility things in here other than this. All right, so now the VBox. Now it should ask the children. So we're going to iterate through the children. Right? We could reduce through them. We need to know what our dimensions are. So oddly enough, this is going to have some of the same functions on it eventually as this, right? Because the VBox is going to need to add itself to its parent. But we'll just stub that out for a moment. We'll say our width is equal to come back to our UI test, 3D scene. We have a stack of 4 boxes there that we want to be stacked properly. Oh, do we want to reduce? We could absolutely reduce. All right. So thinking through this, what I would like to do is I would like to tell this thing that its only constraint, the inner component, that its only constraint is width based. I'm going to say here you have a width, but you have no height that you must adhere to. All right, so here are your dimensions, or this is your sandbox that you must live within. And then I will ask it what its height is, what its dimensions are, because it would be free to become tall. Because let's say it needed to have so much space due to text, right? It had to wrap, which is one of the first things that's going in these. So we will call a function on the child. Yeah, UI layout stuff. And in this case, we're going to call what? Set. I don't know. I think we should split up the difference between width, height, and position. Set position. So we can give it an X and a Y. So the X in this case is going to be whatever our X is. Oh, you made a UI layout, excuse me, layout library at a previous job. I did too, but it was in 2006. it they are fun. And here we're trying to work within the constraints of Godot. So here, 0.0 and variant. This is 2 on variant would be fine. And what is the y going to be? Let x equals whatever. That's going to be fixed. Let y equals, let mutable y. We'll start at 0. Actually, I want to copy that. Oops. Minimax sizes? Let's see, when you min and max, well, rather than max, that this can fill. I thought that we had that. Invoke. Oh, only implemented on an object? It must be a Godot object. Okay. Because we do not know if these have been removed. That's the other thing that we have to do. We also have to implement remove for this. Probably just the child. What am I missing? Ah, that. F64? Fine. F64. I mean, really, we could do F32s or whatever. There's also Flexbox layout as a library. Oh, really? Cross-platform Flexbox implementation. Looks like there's a few. A year ago. This one, Stretch, has more. what is this getting used in? Categories, GUI, author. Bizly.app. Build, React, components visually. Okay, that's neat. Okay, what's the first thing you do when you look at something new? You check the license. For charge, okay, this looks MIT-ish, BSD-ish. Looks like the BSD license. Well, let's see. Is there's something wrong? We can always lend a hand. And it sees versions, creates, downloads. I'm not seeing the documentation button. Where is the documentation button? On the right. There we go. All right, so geometry, node, number, resultant, style, 4 modules. Actually, let's see, do they have, let's check out their GitHub repo. Or, let's go back one. Full supported platforms, Rust. It's interesting. Android, iOS. I mean, isn't this basically everything that Rust compiles to? Usage. Great new stretch. As a node. Style, dimensions, percent, okay. Height, auto, default 0. Compute layout. I see, so I could actually give this. Oh, I see what they're saying now. They actually wrapped this. Ah, that makes more sense now. Why their targets are the way they are. Because for Android they wrap it. For iOS they wrapped it. For iOS, for JavaScript, exported. Okay. Binary size reduction, runtime performance, string build test. Okay. Okay. Let's see. Ooh. Oh wow. Wow. Okay. So they're setting the size, this flexbox element, width, be a percentage, height, auto, everything else is default. I see. So they have defaults for all the different properties of style. Uh, like good to do things. Right? See, people copy and paste code right out of this. I might just do that. And they want you to use the try operator in your examples as opposed to an unwrap or an expect. So that's what they've done here. And what is child? Oh, this is the child. I see. And then this is the parent. And we compute the layout, size being undefined. See, I've got the text renderer, and that's exactly what I'm going to have to figure out is how to do this, because I think what's going to happen is you provide it with a style for your node. Right? This represents the child node. I'm going to have to query it and ask it, what is your width? Right? Given your width, what is your height? And then I can fill this in and lay out the rest. And we compute. What is this? Now let's see what layout does. Maybe there is an interface we have to implement. So we might need some sort of something to go between these. Yeah, stretch style. We looked at style. Result should just have. Okay. I was expecting error to be in there. Oh, there's enum. There's error down here. Let's number. I see. It's either defined or undefined. And we were going to do the same thing with an option. Okay. Min max or else two number. Handy. Two number is implemented for F32s. All right. Geometry. Point, rect, and size. Node. And what about layout? Oh, it's a trait. Trait. No, these are trait implementation. It's a struct. It's a struct that has trait implementations. Let's go back. There's this measure function. New node, new leave. I see. So on an error, we get back this. Maybe. I would think if it's a box dynamic back. What would we do with this? set children. If we have a bunch of nodes. Mark dirty. Interesting. So if something changes size or like text changes, you can mark it as dirty. Handy. All right. We're going to use stretch. Cargo add stretch. Oh, actually, cargo. What features? Stretch. All right, default just with standard. That's fine. But we're in not the right place. Should be in here. Cargo add stretch. There we go. Or cargo check. All right. Each container a new stretch thing. Because we're going to have flex boxes within flex boxes. And it seems like this needs to be at the top level. Auto trades, okay. What does this layout do? Find node, that. Can a node have children? So we can create a new leaf. So if we have a new leaf or a node, then nodes can. So this. So maybe we have the ability to create styles for these. Display flex or none. Position type, relative or absolute. Okay. Anti, good morning. How are you? Yes. Very early on in the stream, I had a camera, but it went away fairly quick. Yeah, I just teased my wife. Got a face for radio. Sorry, ladies. He's taken. All right. What I'm wondering now is, can we represent this as a variant? Yes, good morning for a 10-hour workday. Absolutely right. I'm going to try to kick on crisp again. Testing. Okay, that uses about 3%, but I don't think that we're getting any funky lag. I'm going to check on my audio filters here. See, now if I hit the keys, it's going to pick up everything. Oh, Starlink, how you tease us. You tease. Oh, how do they handle it? Well, I'm going to know what the text size is. I can show you what's going to happen for us. So what we did previously was we got text rendering implemented here. And text, we can actually change, but we're actually tessellating the text. So in this case, we give it the width in meters and it'll wrap. So let's say we want 4 meters. And you can see that it does it again, wrapping the text. So in this case, we are able to render true type fonts and wrap them. Um, all sorts of crazy stuff in there. Look at those curves. Beautiful curves. Look at that A. I mean, if you get close enough, you can see the edges here. But really, I mean, it's pretty good. So this is how we can tell what the size of our text is going to be. We can say, this is your width in meters. Tell us what your height is. Say, oh, I'm getting encoding lag. Why? Starlink's having a bad couple moments. And no good, Nick. Let me know if that didn't come through again. I'm more than happy to explain it. Um, but because I need to know what the width is for this to be able to calculate the height, it's one of the elements I'm looking for in this is how do I provide our node with that information. All right, we're going to go back to this over here. I want to check the repo on examples. Basic example, sure. No, this is This is a horrible example. Okay. Is a width. So maybe we have to set the width on it first. So somehow, say we compute layout for node. Node is the parent of everything here. I mean, why wouldn't we say it's flexbox? Why don't we just change VBox to flexbox? Flexbox, lib. Okay, that doesn't exist yet. Let's come in here. I'm gonna do spatial for this. I mean, really, it could be node. Spatial adds another dimension to node, doesn't it? A node, does it have a location? They do not have a location. Okay. Okay. Sorry, adjusting the audio again. Just save all this, go back to 3D, save. Does nothing yet, but it will have that other flexbox type inside of it. What is it? Stretch? I think we call it stretch. Really? You're not going to kick in the formatter for us? There you go. All right. Give that a build. Close this. Yes.